the formula for the first principle of differentiation, and because of that, I'm doing this tutorial to help you to prove from the first principle of differentiation. Okay, so to prove this one, what we need to do is that we need to know that there is a curve. And then for differentiation, one thing that you need to know is that we just want to find the slope of the curve or the gradient under the curve. That's all. If it is a straight line, we can just find the slope of the straight line. But because this is a curve, it's very difficult to use the simple change of y over the change of x and then find it. So with a curve, it becomes slightly different. So here you need to know that there's a curve. Okay, the first thing that you should keep in mind that there's a curve. Okay, I'm assuming this one to be my curve. Okay, I'm say this is a curve. Okay, and next curve, let's draw our, so this x and then this is y. Okay, I have my x and then my y axis. Okay, and then here there is a point here called point A, and having the component x and then y, and I have another point here which is point B, also having its coordinates to be x plus change of x, and then the y is also y plus change of y. Okay, so it's just x plus change of x because the curve move from this point and then rise to this particular point, so there's a small increment in the x and there's also a small increment in the y, so that's why the y coordinate become y plus the change in y. Just a very small increment. All right, so here we can try to find the trace this point to get our x component. So you can trace it down here and see this is our x1, and you can also trace this one down here. Okay, trace this one down here and we say this is our x2, like this. And then to find the slope of this curve, we just need to join this one to this line, join this line to this line like this. Okay, and then this is the y1 notation, so you can have my y1 notation here, and then my y1 notation here is written as my f of x here, and then I have my y2 notation from this particular, I'm talking about the vertical line from x2 to B, point B. So that's the y2 notation, and it is as, let me just draw something here. Okay, from this point to this point, and it's called f of x plus change of x, like this one. Okay, so from this is f of x, so this point A to x1 is the same as this point here to x2. Okay, so the distance here from point A to this point is a small change of x, so call it the change of x here. And then from this point to point B is also a small change in the y, we call it so change of y here. So with this, then we are free to go. So with a straight line, if I draw a straight line from this point to this point, then it's very easy for me to find a gradient of what point A of A and B. So very easy for me to find a gradient of AB. Okay, so let's take that assumption and try to prove the slope or the gradient of this curve. So we can say that the gradient of AB is equal to change of y over change in x. So change of y here is written as this over change of x is written as this. So basically this is how we prove it. And then our change of y could be written as 1. So our change of y is equal to what? What is the change of y? The change of y is from this place to this place, this small place, this portion to this portion. That's the small change in y. And then you know that for you to get the change of y, I have to subtract f of x from the whole of this. And the whole of this one is what we call the y2, or the notation of y2. So I can say change of y is equal to y2 minus y1, because I said that this f of x is what we call the y1 notation. Perfect. So let's move on and then see what we can do. So what is my y2 notation? My y2 notation is the whole of this from this to this point, which is f of x plus change of x here minus what is our y1? Our y1 is f of x, so f of x like this. Okay, so now we are done with our change of y. What is our change of x? Our change of x is just change of x. Very simple change of x. So our gradient of the curve, that is dy dx, or change of y over the change of x, is not equal to, because I know my change of y to be equal to f of x plus change of x minus f of x here all over my change of x, like this one. Alright, so let's see how we can continue. Know that the change of y is what we call delta. Change of y is something written as delta y over delta x, and then this one is what we call delta, and the delta of x, so delta x, and then this is delta y, and this is delta x. And the delta y and the delta x mean a small increment in the x and a small increment in the y. But we are talking about the gradient of the curve. And the gradient of a curve is actually the gradient of the curve at a point, or the gradient of a curve at a given point is defined to be the gradient of the straight line that touches the curve at that point. So for you to find the gradient of this particular curve, we need to find the gradient about a particular point. That should be when a line touches the curve at only 1 point, not 2 points. So when I'm dealing with point A and point B, then the result that I'll get will not actually be the gradient of the curve. Because if I have something here and I have something here, and I get a gradient, and I have another point here, I'll get a different gradient. If I get another point here and another point here, I'll get another gradient. So the gradient will not be constant. But if I'm able to get the gradient at only 1 point, that's a tangent, the gradient of a tangent to this curve, then actually that one becomes the gradient of the curve. That's why I define the gradient of a curve is defined as the gradient of a straight line that touches the curve at that point. That's equal to the gradient of a tangent. That's actually the gradient of what? A curve. So the dy over the x, or the delta y over delta x, is not actually the gradient of the curve. So we change the delta y over delta x to dy over dx. So dy over dx is now the most important thing. So dy dx now becomes the gradient of the tangent, because now we are dealing with the gradient of a tangent, not delta y over delta x. And then for you to change delta y over delta x to dy over dx, we now equate dy over dx to be equal to the limit as change of x approaches 0. then our formula now changes to becomes this. When a change of x is now equal to 0, then we can say that our dy dx is now equal to change of f of x plus change of x minus f of x all over change of x, like this. So, and dy dx is equal to the limit as change of x approaches 0, and this is actually the formula for finding every differentiation or solving every differentiation using the first principle. In some books, you don't see change of x, but we see h. So when you see h, it's the same. So if, for instance, they are using h instead of x, then the dy dx in that book is going to be the limit as h approaches 0, and then f of x plus h minus f of x all over h. And the point is that the change of x is a small increment in the x, and then h is also a small increment in the x. And the point is that if h approaches 0, it means that when h approaches 0, we want to say that the small increment of x is reduced to 0, and then we now have a gradient of a tangent. So basically, I know that this tutorial has helped you a lot, and now you can prove the first principle of differentiation, and then try to also explain to other people why we have dy over dx and not delta y over delta x in this particular equation. Thank you for watching this tutorial, and then if you do like this tutorial, subscribe to my YouTube channel for more videos like this. Thank you. Of differentiation, and then to solve this question using the first principle, you need to create your formula, and the formula is dy over dx is equal to the limit, limit as change of x approaches 0, f of x plus change of x minus f of x all over change of x. So this is the formula that you can use to find from first principle the differentiation of the question. So now I'll do that y is equal to s squared. So here it means that the whole of this f will occupy by the function. So the function y is equal to x squared. So we just come and we write the same thing, limit as change of x approaches 0 here, and then here's x squared plus change of x. So you come and write x plus change of x here, all raised to the power 2 because of the square here, minus f of x, and then y is equal to s squared, and then f of x is the same as y, so you write it here, the value of y, which is x squared, like this, and then put it here, all over change of x. So now we need to expand the bracket. So by expanding the bracket, write your limit of the change of x approaches 0, and then we have this. So expanding the bracket, we can write x plus change of x multiplying x plus change of x here, that expansion of the bracket, minus x squared all over change of x, like this. and we move on. So let's expand it. We multiply the first x here in the first bracket by the first x in the second bracket, and you have your limit as change of x approaches 0. So you get x squared, x times x will give you x squared, x times change of x will give you plus x change of x plus another x change of x, and then change of x times change of x gives us plus change of x all square. Okay, then minus your x square here all over change of x. Simple like this. So now we can see that there is x square here plus x square here and minus x square here. So definitely this minus x square will cancel this positive x square, and now it will be left with your limit as change of x approaches 0, and then you have x multiplying change of x, another x multiplying, so you get 2x change of x plus change of x square all over change of x here, like this. So we are continuing and have the limit as change of x approaches 0 here, and then we divide the top half of the fraction by the denominator, that's change of x. So 2x change of x over this x means that you're going to get 2x change of x over change of x plus change of x square over change of x, like this. Okay, so change of x will cancel change of x, and then change of x square divided by change of x will give us just change of x. So this one will cancel this one, have change of x. So have our limit as change of x approaches 0, and that is 2x plus change of x, like this one. Okay, so all that I have to do here is simply I have to state a condition here. As change of x approaches 0, then the whole of this expression 2x plus change of x now becomes 2x plus 0, which is now equal to 2x, like this. So this is how we can find, by using the first principle of differentiation, to differentiate this function. So the next tutorial will take another example, and then we try to see how we can solve complex questions. If you like this video, you can subscribe, share, and like it too. Thank you. Alright, very nice meeting you once again. And then this tutorial we are trying to do differentiation using the first principle, and very sharp here. So let's just start. So to do this type of differentiation, all that you need is that you need to code the formula and then go through the formula and then use all the processes that you need to do. Know that y is the same as the function f of x, and then so here all that you need to do is let's write the formula. And then the formula of differentiation say the limit as change of x approaches 0. In some books they'll write h approaches 0. So h talk about the small increment in the x. So some books use h, some use change of x, and then this tutorial I'm using change of x. You can use h and then you'll be fine. So any of them is correct. So okay, the first tutorial I use change of x, but this one I can prefer to use h, but you can use change of x or use h and you all get the answer right. So here the limit as change of x approaches 0, just write a formula here, f of x plus change of x here, put in a bracket, minus f of x here, and then you put in this bracket, and then all over change of x. This is the formula that you need to know basically in order to tackle this question and solve it very well. One thing that you should put in your mind is that here y is equal to 2x squared, and then the 2x squared is the function. The function f of x is equal to 2x squared. So it means that the whole of this is a formula. We substitute the whole of this formula by the f of x. Okay, so the value of x here, we just put it here. So just come and I'll say the limit as change of x approaches 0 here. This 2 being a constant will be outside the bracket, the first bracket. So it's going to be 2 here, and then you put everything in a bracket, put them in a bracket like that. So x plus change of x here, okay, minus, what is the f of x? The f of x is the whole of this one, 2x squared. So minus 2x squared like this, and then all over your change of x. So what else do we need to do? All that we need to do is very simple. We expand, but there's a square here, so the square we apply to the bracket. So apply your square here to the bracket very nicely. All right, so let's continue to break down. So let's expand our bracket. So expand our bracket, our limit as change of x approaches 0 here. Let's expand in the bracket. So have 2, and expand this one, have x plus change of x, then a bracket, and then x plus change of x like this, minus 2x squared like this. So all in this bracket, and then all over change of x. All right, so let's try and then break this one down. So we have our limit as change of x approaches 0 like this. So our expansion, we multiply x by x, and we get x squared, x times change of x, and we get plus x change of x, plus another change of x times x will give us x change of x, and then change of x multiplied by change of x will give us plus change of x squared. So you put them in the square bracket because the 2 is multiplying everything, minus our f of x, which is 2x squared, 2x squared like this. So put them in this bracket, all over change of x here. Very easy. So let's try and then simplify the one in the bracket, the expression in the bracket. So have the limit as your change of x approaches 0, and then have this one. So my 2 be outside here. Let's try and see x squared is here, x times change of x is here and another x times change. So we have x squared plus 2x change of x, okay, plus x change of x squared, all in this square bracket, minus 2x squared. Put them together in a bracket, all over change of x here. Okay, so let's see what we can do here. So let's multiply the two through the bracket and see. We have the limit as change of x approaches 0, and then we have something here. So let's multiply through. We have 2 multiplied x squared will give us 2x squared. 2x squared, and then 2 times 4x change of x will give us plus 4x change of x, plus 2 times change of x squared will give us 2 change of x squared, minus 2x squared, all over change of x, like this. So you also put it in a bracket like this. Alright, so we are here, and what we need to do is that, look at this, you can see 2x squared is here and then plus 2x squared is here. So minus 2x squared plus 2x squared, they can cancel out, or when you just add, becomes 0. So now it will have it, the limit as change of x approaches 0, and then so a bracket. So we just put this one together and we have 4x change of x plus 2 change of x all square over change of x, and then you put them in a bracket here. So now we can divide the top part by the down one, and we have our limit as our change of x approaches 0 here, and it's going to be 4x change of x over change of x plus 2 change of x squared all over change of x, like this. Okay, so change of x will cancel change of x, and then change of x cancel this one, and we'll have it 2 change of x. So now I have my limit as my change of x approaches 0 as 4x plus 2 change of x. Okay, and you should know that at this point, you should know that as change of x approaches 0, our term, which is 4x plus 2 change of x, okay, like this, now becomes 4x plus 2 multiplying 0, and then 2 multiplying 0 give us 0. So finally our dy, the x equal to 4x, like this. So dear friends and students, this is actually the best way and the simplest way we can deal with any question when we are asked to solve them using the first principle of differentiation. You can use it to solve any other question. And then in the next tutorial, we're going to use the formula method to solve this type of differentiations. If you like the tutorial, you can share it, subscribe also to my channel. God bless you. Thank you. We meet next tutorial.